Right, what's up? So today I'm gonna explain about the mechanism of dehydration of alcohol. For me, this mechanism is the most hardest to explain, so that's why I have been leaving it at the back for weeks. So this involves the reaction of alcohol converted to alkene. And in this reaction, you will need concentrated H2SO4. So how does this reaction occur? For the first step, we need to do the protonation of OH group. Alright, in this reaction, we're gonna need to draw this reactants in expanded form because it's the only way to accurately draw the arrows as we go on. So, in this H2SO4, this hydrogen is partially positive and this oxygen is partially negative. So, this H atom will become an electrophilic site. Now the lone pair over here is attracted to this H atom. It thinks, yes, poor people, I can take advantage of this. So this lone pair over here will attack the H atom. And when this H atom is attacked, the sigma bond between the H and the O will be broken and both of the electrons will be pushed to oxygen. Because oxygen is more partially negative, it can actually hold the electron. So after this reaction, it will form a new bond over here. And since the oxygen have used its lone pair to make this new sigma bond, it will be positively charged. While this previously H2SO4 will become negatively charged because it have received the extra electron from the broken sigma bond. Okay, now proceeding to the second step, which is the formation of carbocation by removing water. Alright, after making that new bond with that H atom, the oxygen realized, oh no, I bit off more than I can chew. Why? Because naturally, oxygen would want to have two lone pairs, and now it's beating its natural state. It's using too much electron that it's willing to use. So what it will do to stabilize itself, it will divorce this molecule over here. Is it called molecule or is it called compound? I'm not sure. So this oxygen atom over here will take electron from this sigma bond and form a lone pair from it. And when the oxygen have already taken the electron from the sigma bond, this will form a secondary carbocation. Now proceeding to the third step, rearrangement. Well, after the divorce, that molecule is not good enough. Why? It's only secondary. To proceed with the reaction, we need to make it more stable. To make it more stable, we need to make it a tertiary carbocation. How do we do that? Alright. We need to make a process which is called the 1, 2, oh no, my marker's dying. Methyl shift. I hope you can see that this board is ugly. Alright. This H atom and the charge over here will switch places simultaneously to form this, which is a more stable carbocation, because now you see the positive charge is now at the tertiary carbon. When you draw this step, please don't do my mistake. Don't draw it like this. This is why I was confused for weeks, because I don't understand why it will be like that. Turns out I draw it wrong. So don't do my mistake. Draw it like this. the bond will follow the H atom, and the positive charge will be here. Okay, now we proceed with the fourth step, which is the deprotonation, the loss of proton. Alright, now that we have a stable carbocation over here, the negative OSO3H will want to revenge. You see, it is still yearning for the H atom that was stolen in the first step earlier. So what it will do, it will steal this H atom over here, and once it has reclaimed the H atom, the electron from the sigma bond over here will be pushed to here. So in this swift attack, H2SO4 will be reformed, while a new double bond will be formed here. But here's the thing, you can draw it like this or like this, but why is this the major product? So to determine the major product in alkenes, we use Zaitsev's rule. As always, the definition is long, but in a nutshell, the definition is the more alkyl group attached to the double bond, the more stable it is. So let's look over here. The alkyl group attached to the double bond here is 1 and 2. Meanwhile, the alkyl group attached in this double bond is only 1. So I reckon this alkene is more stable than this one, according to Zaitsev's rule. And the side product will be water. The water came from where? Oh, from the second step, from the big divorce, remember? So with the formation of the major product and the side product, our reaction is complete.